Alright, so we will talk about how to approach the application questions involving vectors, addition or subtraction. We have some terminology which is commonly used. I'm gonna just talk about those things, and then we take few examples to understand how to approach to vector addition application question. The only difference, if we don't have a diagram given, we have a statement given. The word problem involves a statement, and by reading the statement carefully, we have to figure out what those vectors are given. The next step, we should put those vectors on a triangle by using head to tail method. The tail of second vector should be at the head of the first vector, and then we use trigonometry concept to solve them. The triangular law of heading vectors or cosine law. This kind of questions are easy to do sometimes when we learn how to use the rectangular component method, the components of vectors. We add the corresponding components of all the vectors, and then we make a right triangle. But I'm not using that method. We will be learning about the rectangular components of a vector method in a different video. So I'm going to just talk about how to use the triangle of vectors, the triangular law of heading vectors, or simply using trigonometry concept of to find the sum and difference of the vectors. So some of the commonly used term is called the ground velocity. Normally the air traffic controller, what air traffic controller sees the speed of the plane and the direction of the plane. That's the ground velocity. So for example, a plane is flying in east direction and there's a wind coming from a different direction. Plane will shift its direction. The pilot is still going in east direction, flying in east direction, but because of the wind, direction is probably changed to the north a little bit, or maybe a little bit south. So what air traffic controller sees, that's called the ground velocity. Means that the velocity of the plane with respect to ground. And velocity of the plane with respect to air is called air velocity. And heading what direction the ship is going or the plane is going, that's called the heading, that's a direction. The tailwind, when wind is coming from behind, basically when the wind will increase the velocity of the plane or a boat, it's called tailwind. When it will reduce the speed, it's called nose wind. Means the direction of wind is coming from opposite direction of the plane, or even in terms of ship. And the equilibrium vector is basically the resultant of all the vectors, and this vector will be in opposite direction to the resultant of vectors to make the sum of all vectors equal to 0. For example, there are two students trying to push a desk, and we have one person which is actually applying force from opposite direction of the direction of motion of the table to stop it. That's called equilibrium vector. So a vector which is the opposite of the resultant of all the vectors is called equilibrium vectors. The rectangular components, I did say any vector when we can add sum or difference of two other components, it's called rectangular component. We will talk about this in a separate video. Tension is a type of force which is actually appears when in a string or any other material, for example, a cable, or we have a wire, or even a cloth, for example. We try to apply force from opposite direction, the tension appears in that material. It's a net force acting along the wires used to balance the weight of a heavy object. For example, we are hanging something on a wire. The weight of the object is acting downward. The tension which will appear in opposite direction is balancing the weight. So that's tension. This is kind of force we use in physics. You can also understand I have few diagrams included. So this is velocity of the plane with respect to air. plane is flying in this direction, wind is going in this direction, the plane will end up going in this direction. So this is the vector sum of the plane velocity with respect to air and wind velocity with respect to ground. So plane will be going in this direction with the ground speed of vpg. Same thing if we have water current, for example. If suppose this is the direction if the boat is supposed to go, but water is flowing from opposite direction like this, so definitely the plane the boat or ship must be going in this direction, so that when water is flowing from opposite direction, its direction is changed. So if let's say this is the desired path, but if ship or the boat is actually going in this direction, it will end up going in this direction, so its direction will change. So this is another example of adding vectors, and this is concept of tension. Suppose there's a weight hanging here and the tension appears in this cable and tension appears in this cable, will be acting in this direction, so the net tension will be produced in this direction here by combined tension in both the strings. So that's actually balancing the weight. So this is the other example of equilibrium vectors. D net, which is sum of those two tensions, and weight is in opposite direction. This is called equilibrium vector. So situation like this, so I have one of the examples like this one, like tension. I'm gonna do, so let's try doing some questions. I already have the solution, but I'm gonna just go over how these solutions are made. So let's read the question. Question says, I'm gonna change the color. Airplane is flying at airspeed of 450 kilometers per hour on a heading of 050, means it's going 50 degree east of north, and wind is 120 kilometers per hour blowing from, see, this is another thing we have to remember, from and to are two different things. When wind is coming from a bearing of 130 degree, that means it's going in opposite direction, right? So that means direction will change by 180 degree. So 180 plus 130 is actually going in the direction of 310. So I made the diagram. So we have to find the resultant of these both these vectors, the velocity vector of the wind and velocity vector of the plane, and we want to see what's actually ground speed of the plane. So plane is actually flying at 450 kilometers per hour, heading of 050. This is what the air traffic controller sees, not sorry, air traffic, this is the pilot sees. And the wind is coming from 120 kilometers per hour, that means it's going in the direction of 310 degree. And we show these individual vectors here. So you can see this first vector here. The first vector 450 kilometers per hour. This is the velocity of the plane with respect to air. This is air speed. At 50 degree east of north, and wind is coming from 130. That means it's actually going at the direction of 310 degree. So that means exactly 40 degrees north of west. So wind is actually flowing in this direction at a speed of 120 kilometers per hour. And we put these vectors on a triangle of vectors. We show the vector, the airspeed here, velocity of the plane with respect to air, and then we show velocity of the air with respect to ground at 40 degree north of west, and the plane will end up going in this direction. This is the velocity of the plane with respect to ground. We need to know what's the magnitude of the ground speed of the plane, also ground velocity of the plane, and also what direction is plane going now. So that will be beta. So that's the triangle of vectors. So now we can write vector equation. Velocity of the plane with respect to ground is velocity of the plane with respect to air, and velocity of air with respect to ground. So normally you see this A, this is also A. When we find the vector sum of VPA plus VAG, it will simply become P to G. So that's the velocity of the plane with respect to ground. That's called the ground speed. This is what air traffic controller sees. This is what the pilot sees. This is the velocity of the wind with respect to ground. So from the diagram you understand this is a 40 degree. The wind is blowing at 40 degree north of west, and this angle will be 40 degree if you complete this triangle. So this is also 50 degree because this whole angle is 50 degree. This is also 50 degree. They are equal, and using the Z pattern you understand. So this is 40 degree. So 44 plus 40, the head to tail angle between the velocity vectors is 80 degrees. So then we can use the cosine law. You can use the triangular law of adding vectors, but then you have to use angle 100 degrees, but then this will become positive sign here. But I simply use the cosine law, substitute all those values, and then find the answer. The magnitude of the velocity of the plane with respect to ground is 445.14 kilometers per hour. It's actually going 450. The wind is coming from opposite direction, which is actually not 100% opposite, means not from 180 degree opposite. It's a nose wind. Wind is coming from opposite direction. To reduce the speed of the plane, that will reduce to 445.14 kilometers per hour. Now we need to know, because vector the finding magnitude is not enough. We also need to know the direction of this vector. To find the direction, I can use the sine law. If I can find alpha, then I can subtract from 50, I can get beta. Beta will give us the direction. That's a bearing direction. To find alpha, I can use sine law. So sine alpha over velocity of air with respect to ground equal to sine of 80 degree divided by velocity of the plane with respect to ground. So I did these calculations. If you see, the alpha comes out to be 15.4 degree. But to show the bearing angle, we have to subtract alpha from 50 degree to find beta. So that's what I exactly did here. So beta comes out to be 50 minus 15.4, which would be 34.6 degree. Then I can write my answer. So that means the ground speed of the plane is 445.1 kilometer per hour at 34.6 degrees. That's a true bearing. If I want to write as a direction in terms of the compass method, then I have to write north 34.6 degree east, or I can write east 34. I can subtract from 90 to find the angle, the others from north of east. So that will be 55.4 degrees north of east. But question is given in terms of bearing, so we have to write the answer in terms of bearing direction. Clear? So this is one of the example. So let's talk about one more. Again, I made the solution. This is a question on finding the tension in the cable. So let's read the question. A traffic light at an intersection is hanging from two wires of equal length, making an angle 10 degree below the horizontal. This is actually the diagram. So the tension, this is one cable, this is the other cable, and they are 10 degrees below the horizontal. And weight, this is traffic light which they're hanging. So weight means always acting in downward direction towards the center of the earth. So therefore tensions must be acting in upward direction like this. So this is tension T, this is also tension T. In this case, because lengths are equal, angles are same, therefore the tension in both the cables will be equal. So because angle is same, 10 degree, and length of the cable is same. So this is actual diagram. Now we want to show this on a triangular vector. So I exactly did this here. The weight is acting in downward direction. This tension is 10 degrees. So if you look at this one here, this tension here, I put it here. This tension is 10 degree in this direction here. This is also 10 degree angle. This is also 10 degree angle. The total angle, the head to tail angle comes out to be 20 degree. So T2, T1, actually I put T1 and T2, but they are actually equal, so I put it here. So the angle between them is 20 degree, and the third side is given 300 Newton. That's the resultant of these two tension. So I can use cosine law again. So I did T square plus T square minus 2 times T times T times cos 20. Anyway, so I think you will understand how I did. Simplify, isolate for T. The tension in each cable comes out to be 863.82 Newton. It's equal tension in this case because the strings are same in length. The angle below the horizontal is same, 10 degrees. Therefore, the tension in each cable has to be same. I wrote a note here. This one can be done more easily actually by using the component method. We will do this question later on when we understand the component method. That will be in a separate video. So we will learn how to add or subtract vectors using component method. I didn't use component method. I simply used the triangular law of adding vectors. I hope you understood. Let's move to one more question and then application questions on vectors. You can find thousands and thousands of questions. Main thing is you need to know how to approach. The first thing you need to know, what are those vectors, what are the individual directions given, and then how you can put on a triangle if you have to use the triangular law of adding vectors or simply trigonometry using cosine law. You need to know how to put them on a vector diagram, and then we need to solve it using trigonometry. I have one more question. There will be many questions like this. We can take up more questions like this. So a motorboat is traveling at 4 meters per second in east direction and encounters a water current basically traveling 7 meters per second north. So first part we have to find what's the resultant velocity of the motorboat. When we say resultant velocity, that means we have to find the magnitude of the speed of the boat, and we also need to know the direction. So I have individual vectors here. The velocity of the boat with respect to water. Boat is actually going at 4 meters per second in east direction with respect to water. And then water, velocity of the water with respect to ground is 7 meters per second. Water is flowing at 7 meters per second in north direction. If you put those two vectors on a triangle of vectors, this is what situation is. So we have the water is in this direction and the boat in this direction. This will end up a right triangle. So solving is much easier. We can simply use Pythagoras theorem. So if I want to write vector equation, I have to write velocity of the boat with respect to ground. This is the ground velocity of the boat. It will be velocity of the boat with respect to water plus velocity of water with respect to ground. So you notice similar to what we did up there, the airspeed of the plane, and this is W that stands for water, so it will cancel out. This will become B to G. B to W plus W to G is same as B to G. So in other words, the velocity of the boat with respect to ground is velocity of the boat with respect to water plus velocity of water with respect to ground. We wrote the vector equation. To find the magnitude, we can simply use Pythagoras theorem. So I found this value 8.06 meters per second. That means boat is going at 8.06 meters per second with respect to ground. So if somebody watching the boat is actually going at this speed, and the direction is also different. Boat is actually trying to go in east direction, but it will end northeast. Next step is to find the angle, what direction boat is actually going to. So this is the angle alpha. This is simply right triangle. I simply use trig ratio, and we have opposite side given, we have an adjacent side given, so I can find the angle alpha. And this alpha is actually east of north. So the velocity of the boat with respect to ground is 8.06 meters per second. It's north 29.74 degree east. Or you can write north of east, which will be initial direction east, then going 60.26 degree north. That's the A part. So this is simply a right triangle. It's easy to solve, but otherwise you have to find the angle, head to tail angle between the vectors. In this case we know it's 90 degrees. Next one, if the boat has to go through the river, which is 80 meters wide, how long it will take? Remember, boat is still going in east direction. This is the direction of the boat. Boat is trying to go in opposite direction, and it has to travel 80 meters. So it's simply using distance, time, velocity formula. So the velocity of the boat is given 4 meters per second in east. The width of the river is also in east. We can find time it will take. Even though velocity of the boat is actually more, appears to be more for a person standing outside on the river, 8.06, but boat is actually going with respect to water at 4 meters per second. In east direction, it has to travel 80 meters distance, so that means boat will take 20 seconds to cross the river. It's a different story that boat will not end up in opposite direction. It will actually going in a different direction. I will show you in a different diagram to explain it. So boat is trying to go 80 meters east at 4 meters per second east. It will take 20 seconds to reach the other side. Next part of the question here, I'm going to go back here. The last part. What distance downstream does the boat reach the opposite shore? Now we need to know, boat is trying to go, let me see this diagram again. So water is flowing in north direction. Boat is trying to go in this direction. Because of water flowing in this direction, boat will end up reaching here. Boat will take 20 seconds to cross this river, but in 20 seconds water will travel this much distance. So D is the distance water will travel in same time. So how far water will travel in those 20 seconds, that's how far boat will end up going downstream. So that's what exactly I did the question here. So water is going at 7 meters per second in north direction. At 20 seconds, in 20 seconds for the time boat is in the water will have traveled 140 meters downstream. So that's how far the boat will end up coming on the other side. So that's this question. So I can take a few more examples, but I think that should be enough to start doing some of the questions on this section. Basically solving all those word problems where we have to add and subtract vectors. So I just decided some examples to take up. Okay, so you can browse again once more. This is my first example and check how I did. I can pause for a second to see, or you can play the video once more. You can go back to the explanation of this example, and then I did second example. I still use the triangular law of adding vectors. I didn't use the component method. Once we learn the components, the concept of components of vectors, I can show you this kind of question once more in a different way. Third one is the boat question, and I'm gonna just move a little bit. You can see the solution here. First part is only to find the resultant velocity of the motorboat, and then second one, how long it takes to cross, and third one, where on the other side the boat will end up coming downstream. And that's it. So try to do some practice questions on this section. Then I will talk about the components method, then how we can use the components method to find the sum or difference of vectors. Once you know the components method, then you don't have to follow a specific method. You can use any one of those methods. Actually, component method works much better if you have more than 2 vectors to add. It becomes much easier. Alright, so hopefully you will like my lesson and then ask me questions if you have. I can try taking up those questions too. Alright, thank you so much. Bye.